Our next presenter is going to be Tim Woolery. He is the Vice President of Sales for Advanced Chemical Technologies in Oklahoma City, Oklahoma.
We've heard a lot about repair today, tearing things up. Well, we're going to talk a little bit about prevention today. So instead of tearing stuff up, we'll try to get it before it gets all torn up. We're going to talk a little bit today about what silanes are, a little bit about the chemistry. We're going to go through application. We'll go through the testing of the silanes, how long they've been tested, and they're continue to be testing. And then we'll go through the costs and longevity. Water is the true enemy of your concrete. That's everything that we've been talking about today and through this whole conference is what's destroying our bridges, and it's the water. When you're using de-icing salts, and then it rains, and then that de-icing salt gets down to the rebar and it corrodes it. So we're gonna stop that today. Freeze-thaw damage is one of the most things that we're fighting. Spalling, I can't even see my own. Scaling, I can see it right here, can't I? Cracking. ASR is not a huge problem in some states, but in some places it is. And so when you have ASR, what has started that is the water getting into that concrete and expands it, and then it blows up on you. This is the one thing that I've been seeing around the country as I go. We're doing a lot of great work on the bridge decks, but then the substructures are just getting corroded like crazy. Well, if you look at your expansion joints pouring over the side of that bridge, you're going to see this running down the side of your bridges. If we would silane those, this would stop. But this is another example of what I see as I travel all over the country. We're doing a great job on the bridge decks, but it would take no time at all and very little effort for our maintenance crews to stop this kind of damage. So why should we use silanes? Well, they work. They're simple to apply. They're real easy for maintenance crews to apply. Anybody can do it. They're extremely cost effective, which we'll go through here in a few minutes. They last for years. Studies have shown how long they last, and we're going to look at that. They don't change the skid resistance. They don't change the appearance, and they dry fast. The one thing that we're always worried about is lane closures. And so if we can't close these lanes down for very long, or somebody in your office gets a phone call, or the governor does. So we need to get the bridges repaired and fixed fast. So we need to get on them and get off of them. So what do silanes do? They turn the concrete from hydrophilic to hydrophobic. Silanes are not a film former. They soak into the concrete and they just disappear, and you go, well, how can this work? I don't see anything, but what happens is it forms a covalent bond with the silica in the concrete, and it makes the concrete water repellent, hydrophobic. This is loose sand that's been treated with silane, and as you can see, that droplet of water just sits there. And so you could tell that it's not forming a film on that sand. It's purely just impregnated that sand, and then it makes it hydrophobic. This is what it does to the concrete. When you spray it on the concrete, it soaks in, penetrates in there up to a 1/4 of an inch, typically, depending on the application rates, and then it keeps the water out. It does allow, though, for vapor permeability. So if the concrete is wet already, so what it does is it makes the concrete hydrophobic, but allows for vapor permeability. So if there is water in the concrete, it allows for that concrete to get drier. And studies have shown that over the years, the concrete actually does get drier. Silanes. A lot of people are selling silanes. What you need to know, and we'll get to spec writing in a minute, is there's not that very many varieties out there. It's a big, long chemical name, but there's very few actual concrete repellents out there. Everybody basically has the same 6 chemistries. So there's isobutyl trimethoxy, isobutyl triethoxy, isooctyl trimethoxy, and then there's like the isooctyls. So they basically all function the same. The big difference between them is the dry times. A lot of them have a very slow dry time, some of them are very fast dry times. But when it comes to actual performance, they are all basically the same. What's going to happen is, we'll talk about application rates in a minute, and what happens is when you write your specs, we want a consistent specification written. There's water-based silanes and solvent-based silanes. So typically these are reduced versions and not the neat silane. The difference basically is that solvent-based ones dry much faster. They penetrate a lot deeper, They dry, but they do dry a lot faster. They can be formulated to meet any VOC requirement there are in the country. Once you start doing that, though, and modifying them to change the VOCs, you actually add cost to it. So actually, using this pure need 100% reactive silane is probably the most cost-effective for the state DOTs to use. One of the questions is that you see is, oh, it's 100% solids. These, if they were 100% solids, then there would be zero VOC products. So silanes are 100% reactive. They are not 100% solids. They are 100% reactive, or they're 40% reactive. So it's a confusing thing when some people will write a specification that says, well, I want 100% solid silane. That does not exist. They're 100% reactive. The waterbornes are typically lower in VOC, but they are a lot slower drying. If you're trying to get on a bridge and get off the bridge, you're looking at a 4-hour dry time probably for a waterborne. And if it's humid or cool, it's even longer. So you're trying to get on a bridge, get off the bridge, and we make water-based products, as do all the people that make silanes. But if you're trying to get on that bridge and get off that bridge, my recommendation is always 100% silanes. Silanes have been tested by every Department of Transportation probably in this country, and they are still being tested by Department of Transportations. They have been tested. It started in 1976 in Oklahoma. They did a 10-year study, and we're still testing in Oklahoma. Universities are still studying. I just sent some samples to Nevada just a few months ago for them to start a silane study. Oklahoma State's still doing studies on it. They just did a great big recoat study that I've got a slide on that here in a minute. But it's like we don't believe they work. It's a little bit crazy. This is a Wisjane-Ailes report, Elsner, from 1985. 1985, they did a 48-week study, a salt ponding study, and after the 48 weeks of saltwater ponding on blocks, 2 weeks on, 2 weeks off, there was zero corrosion on the rebar. That's from 1985, and we're still testing. These are a lot of the tests that you'll see when you're writing specifications, the freeze-thaw, moisture absorption, chloride, it just goes on and on. Well, anyway, can you come get that? These are called rylum tubes. And if you've never seen these, this is what you can put on concrete to do testing. And what you'll see is it actually absorbing the water. It's a time delay study. Whoops, there we go. Sure. Anyway, that's a rylum tube study. And so what that does is you stick those to the concrete, and it'll start absorbing water or it won't absorb water. And that's how you can determine if your silane's working or what the permeability of the concrete is. We've got some good slides. This is the slide from Oklahoma State University on longevity. They tested 60 bridges in Oklahoma, and in those bridges, in 6 to 12 years, 100% of those bridges still had silane. So when you ask how long does silane last, there's a study that says it lasts between 6 and 12 years. The bridges that were 15 years old, there was 66% of them still showed silane active in them. Bridges that were 17 to 20 years, 21% of them still had silane in them. So it's a very cost-effective way that lasts a long time. Let's talk about surface preparation and just application. Silanes are one of those things that's easy for maintenance departments to do. Surface preparation could be as easy as sweeping it. You can power wash them. You can shot blast them. Example of a shot blaster. This is a drone photo of a bridge we did in Oklahoma this last year, showing a shot blaster. We like shot blasting. The thing that it does is it cleans the deck a lot better, and it allows for a lot better penetration into the concrete. If you're just going to blow them off, your penetration isn't going to be as good as if you shot blast them. It definitely opens up the pore. In Oklahoma, we pay on depth of penetration. So the contractor applies the silane to it. They pull a core, submit it to the state. They test moisture absorption on that core, and they also test it for depth of penetration. If they do not receive the depth of penetration, that contractor does not get paid. Application, this is a spray bar. This is a new bridge in Arkansas. applying it this way is about 100% transfer efficiency. A lot of places we put a blue dye, and a lot of other people put blue dye. That way you can inspect it to make sure that the treatment got applied. But it's a pretty low-tech application. They're applying that at about 125 square feet per gallon at that application. So with this particular device, they just get a puddle and they kind of push it. This is a truck-mounted application that a lot of contractors use. Pretty efficient way to do it, but you can tell that spray bar is a little bit higher up off the ground. This is Indiana DOT with one of their first trucks that they did. Their maintenance department are actually applying this. There's a good bad thing here. Do you see how high that spray bar is off the ground? That's good for the Silane manufacturer, bad for the state. So it's not very transfer efficient. While we were standing there on that bridge deck, and I think Frank Saylor was here a minute ago, we were eating that stuff. But it's a pretty efficient way to do it. If you're going to set up traffic control, one guy's in the truck, one guy's doing the application rate, but you just have to be timing that truck to drive at 3 miles an hour is kind of difficult to do. Then there's Handspring. Not the most efficient way, obviously, but if you're doing the barrier walls, this is Illinois, if you're doing the barrier walls and you're doing the tops, it's a great way to do it, or if you're doing over the sides. So, when it comes to writing specifications, most testing of silanes is done at about 11 grams of silane per square foot. So if you're going to use if you're going to use a 20% silane on your specification, then that needs to be applied at 60 square feet per gallon. If you're going to write a 40% silane specification, then it needs to be at 125 square feet per gallon. And if you're going to write a 100% silane specification, it needs to be at 300 square feet per gallon. Nobody puts more silane in a bucket than anybody else. A gallon bucket only holds a gallon. So the next guy that walks in the door, or lady that sells silane, well, mine will go 400 square feet per gallon. Well, it will. And it'll go 500 square feet per gallon. But when it comes to the testing and you want it to work, it needs to be at that 11 grams per square feet, which is on 100% silane, is about 300 square feet per gallon. This keeps the spec good for the state. It keeps it competitive for the contractors and the suppliers, but it gets the state what they want. And that's the goal, is protecting the bridges. So let's talk about the cost. If on a 20% silane, if you applied at 60 square feet per gallon, puts that 11 grams of silane per square foot. If that cost per gallon is about $15, let's say, that's 25 cents a square foot. And once again, we saw that it lasted about 6 to 12 years. We like to see a recoat about every 5 years. We think that's because bridges change, they crack a little bit. On a 40% silane, applied at 125 square feet per gallon. Once again, you get that 11 grams of silane per square foot. If that costs you $20 a gallon, you're looking at 16 cents a square foot. So why is it getting cheaper? On 100% silane, at 300 square feet per gallon, once again, that 11 grams per square foot at $35 a gallon, 12 cents a square foot. So it keeps getting cheaper the higher you go up in silane, because the manufacturer doesn't have to touch it. Basically, when you get the 100% silane, that is the raw material. So if we have to take it out of that container and we have to add solvent to it, and then we have to quality control it, and then we have to put it back in that bucket, the price is going to go up. But when you buy the 100% silanes, the cost goes down actually per square foot. So you get more bang for your buck when you do it that way. So let's look at the math. If you have a bridge that's 150 feet long with 38 feet wide, that bridge deck is approximately 5,700 square feet. I did a study one time on bridge costs, and it was around $140 a square foot to build a bridge probably a couple years ago. It's probably more than that now. But that bridge would cost you $800,000. That same 5,700 square feet with a 40% silane takes 45 gallons at $20 a gallon. That's $912 to protect an $800,000 investment. That's not a lot of money for that investment. It is one of the most inexpensive things you can do to protect your inventory that there is. It's easy for the maintenance people to do it. You can bid them out. If you have a washing and sealing program or just a washing program, it ought to turn into a washing and sealing program. But sealing these bridge decks is one of the things that it just works, and it's easy to do. So Silanes are tested, they're proven, they're a great bridge protective treatment. It's never too late to start a Silane treatment. Even if the bridge already has chlorides in it and you start Silanes, that chloride stays where it is. That chloride does not migrate through that concrete by itself. It takes water for that to resolubilize and then melt and flow down to that rebar. So even if you haven't started a Silane program and you have a chloride problem, you can still start that, and it's going to stop that chloride where it's not going to go up anymore, and it's not going to migrate down to the rebar. Silanes are cost effective. They're easy to apply. Maintenance crews can do it. They're setting that up over and over in states everywhere. Indiana's set it up. Michigan's starting that program. Maine's looking at doing those kind of programs. It's just an easy thing for your crews today. They also last a long time. Studies show that they're going to be in that concrete from 6 to 12 years. Like I said, we like to see people go in about an every 5-year recoat program just because the bridges start having cracks in them. There's only two kinds of concrete, right? Concrete that's cracked and concrete that's going to crack. So if you keep a Silane program going, you're going to keep that water out of those cracks.
If you treat a bridge deck with Silanes, can you later apply an overlay or a crack filler on top of it?
Yes, you can. Yeah, the question was if you have Silane treatment or a treatment program, you need to put an overlay on it. Yes, you can. Yeah, that's the one thing about it is you can put stuff over Silanes. It's not like it's you're once and done. The one thing about if you're going to do waterborne Silanes, the next time you go to reply, you're going to be using a solvent-based anyway because you've made the bridge hydrophobic.
For applying Silanes to a vertical surface, it would seem that you're going to get less Silane per square foot trying to spray it onto a vertical surface than a horizontal surface. How do you ensure that you're getting the right amount on the vertical surface?
So, do you ever hear the question about applying to a vertical surface, about application rate? What you can do on the vertical surface is probably apply 2 thinner coats, and just apply right almost wet on wet. You get the first one to soak in and spray the second one over the top of it, and then that way you can get it done that way. And typically on a vertical surface, it doesn't require quite as much on there because you don't have water sitting on it. It's running down it.
I guess I got 2 questions. One is, what's the difference between Silane and siloxane?
Okay.
And the other is, regarding overspray with this, as you have cars going by, what type of damage can this do to a car going by? We get suits against us for spraying water on bridges. So.
Right. The difference between silanes and siloxanes. These come from silicon. Okay, so if you imagine that silicon is the base molecule that you're starting with, silane is the second cook, and siloxanes is the next cook after that, as you separate that out of that raw material. So the difference is that siloxanes is a larger molecule, basically does the same things as silanes, except it is a larger molecule and does not penetrate as deeply. You'll see siloxanes on buildings, but you won't see those on bridge decks, typically. Overspray, if you keep that spray bar down low with low pressure, there is no overspray. But it's not going to damage cars, glass, tires. So if it gets on there, it should just wipe right off. But if you keep it low pressure spray, like that spray bar where it's this far from the ground, there is no overspray. They're spraying bridges all the time in Oklahoma with the traffic going right by them. But if you were using that hand sprayer, yeah, it would be a little bit of it. If they blasted towards a car, you probably would get a phone call. But it's not going to damage the paint. Not that little bit anyway.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.